Okay, so we're gonna talk about linear inequalities. So this is my equation, my inequality right here. We're gonna plug in this point. This is the point x, y. Your x value is 7, your y value is 4. So I'm going to replace the variables with my point. So this will be 4 is greater than or equal to -2 times 7 plus 9. I plugged in that point into the inequality. And the question says, determine which points satisfy the inequality. Which one makes it true? That's what it's asking. So guys, what's -2 times 14? I'm sorry, what's -2 times 7? -14. I kind of gave the answer. Okay, so is 4 greater than or equal to this? What's -14 plus 9? Is this a true statement? Yes, this is true. This is true. So that means this point satisfies the inequality. It's true. You guys are going to test these other 2 points on your own. Okay, you're just testing the points to see if they are solutions. Next, let's talk about a word problem involving inequalities. So it says John sells t-shirts. Plain shirts cost $5 and graphic shirts cost $7. So basically, it's $5 for every plain shirt. I'm going to let plain shirts represent X. And the number of graphic shirts represent Y. Or let Y represent graphic shirts. And $7 for each graphic shirt. In order to match his product costs, he must make at least $1,200. This is his goal, to make at least $1,200. Now, would he like to make more than that though? Wouldn't he like to make more money than what he has? That's just his goal. So I'm going to put, he wants to make more than, greater than, or equal to 1,200. He's happy if he makes 1,200, but if he made more than that, he'd be even happier, okay? So this is a key thing you need to know. When it says at least, you're most likely going to use a greater than symbol. It's opposite. Okay. Question B. If he sells 150 plain shirts and 60 graphic shirts, will he be able to cover the product costs? Let's see. So for plain shirts, he got 150 plain shirts and 60 graphic shirts. Okay, so calculate this. What's 5 times 150? 750, okay. And what's 7 times 60? 420. Is this greater than or equal to 1,200? Did he meet his goal? No? What is this? 1,170? Thank you. That is not greater than or equal to 1,200. So the answer is no. He will not be able to cover his costs. If he only sells that much merchandise, he won't cover his expenses. All right, let's look at question C. If he sells 90 graphic shirts, so we have 5 for plain shirts, 7 for every graphic shirt, and he said that they sold 90 graphic shirts. What's the minimum number of plain shirts he needs to sell to break even? So if he wants to make 1,200, just solve that and figure out how many shirts he needs to sell. I'm going to let you guys figure that out. Nice. Okay, let's go ahead and move on. Now we're going to practice graphing these things. So if you want to graph an inequality, your first step is to put it in slope-intercept form. Slope-intercept form means x plus b, where this is your slope and this is your y-intercept. Okay, we have to put it in this format first. Luckily, this first example is already in the slope-intercept format. So first, you're going to plot this point -1 on your y-intercept. If you haven't done that already, go ahead and do that. Your slope is 2/3, meaning you'll go up 2 over 3. Up 2 over 3. You can also go this direction. Okay, so that's my line. Now let's look at the notes. You're going to use a dashed line for these symbols and a solid line for these symbols. So guys, what kind of line will I use for this symbol? It'll be dashed because we don't have an equal sign, so it will be dashed. So guys, go ahead and connect these points with a dashed line. Okay, what symbol is this called? What symbol is this? It's a less than. Guys, remember, this looks like an L for less than. If it looks like an L, it's a less than. So guys, you're going to put your pencil on your line and go straight down. You shade below for less thans. We want to be less than this line. So this is the side that you shade. Anything in the shaded area is a solution. Jackson, can you give me a solution? A point. What point works here?
Anywhere in the shaded area?
So give me one.
-2, 0.
-2, 0.
No, 0, -2.
0, -2 right here. Yes. 0, -2. That works. Can someone give me another one? What's the solution?
4, -5.
4, -5. Yep, that works. That's in the shaded area. Guys, what about this one? Does this work?
Yes, wait, no.
Why did you say no?
It's because it's a dashed line.
Exactly. It's a dashed line. So this one is not a solution. So this is point 1, 2, 3, 4, 5, 6. So 6, 3 is not a solution because it's on a dashed line. Okay? Let's try another one. What's my y-intercept here? 0. Start at 0. Your slope is -4. So go down 4 over 1. Down 4 over 1. You can also go this direction. Up 4 to the left 1. What kind of line? Dashed or solid? Solid. Why? Yep. Greater than or equal to. If you have that little equal sign, you're going to have a solid line. So guys, put your pencil on the line and you go straight up. You shade above if you have a greater than symbol. This is the greater than symbol. Greater. So you need to shade up. Question, guys. Is this a solution?
Yes.
Why? Yes, it's on a solid line. So -1, 4 is a solution. Next example. This time we have to do a little bit of algebra. Are you guys ready? First, we move this 9x to the other side. Whenever you move something, what happens? Yep, we do the opposite. So in this case, it will become -9x. You do the opposite. Now, I'm going to divide everything by 12. Those canceled out. What I am left with is y is greater than or equal to. Let's simplify these fractions. I can divide the numerator and the denominator by 3. 9 divided by 3, well, this is negative, so -3 over 4. -60 divided by 12 is 5. So this is my new inequality. Let's go ahead and graph it. So go down to -5 and put a point. That's your y-intercept. Your slope is -3/4. I'm going to go up 3 to the left 4. Up 3 to the left 4. You can also go down 3 to the right 4. We're creating a line that is decreasing because it's a negative slope. What symbol is this, guys?
Greater than or equal to.
Yes, greater than or equal to. So that means we need a shade above. We have to be greater than the line. You shade up if it's greater. So put your pin on the line and go straight up. Okay, I'm going to show you one last thing. What if we have 2 equations? Try it. Try it on your own. Graph both of them this time. Okay, this is the first one. You started at -1 and you went down to over 3 to plot your points. What symbol is this first one? Yes, it looks like an L, so it's a less than. That means you should be shading below. Guys, shade lightly. Shade very lightly, because we have to graph 2 of them, so shade very lightly. Your next one is at -8, so I'm going to put a point at -8 right here. And you're going to go up 1 over 2. So this is your other line. What symbol do we have here? Greater than or equal to. Okay, so put your pin on the line, you're going to go up. Do you guys see the area that's double shaded? All of this. Let me highlight the double shaded area. The double shaded area is where your solutions are. So all your solutions are right here. These are your solutions. It's below the first one, but above the second one. So this is your solution. That highlighted part. So guys, question. Is this a solution?
Yes.
Why?
Because both of them, greater than or equal to.
Yep, they intersect on 2 solid lines. Is this a solution? Is this a solution? Yes. Is this a solution?
Yes.
Is this a solution? No. Now, question. What if this was a dashed line? Would this intersection be a solution?
No.
No, good. Solutions are on intersections of solid lines and in the double shaded area. Yes, this is it's on a solid line, but it's also on a dashed line. So it would be true for this one, but it would be false for this one. Okay, so it has to be on solid lines to be a solution.